Welcome to my channel. In this video, I am going to discuss about systems and its classifications. System, this is one device which operates on certain signal xt and it produces one corresponding output or response, that is yt. So here the x of t is called input signal or excitation, and the corresponding output, this is yt, this is the output signal, or it is called response of the system. The system may contain several subsystems like the communication system. In communication system you will find three subsystems. One is transmitter, channel and receiver. And again, in transmitter there are several subsystems like modulator, power amplifier and transmitting antenna, all those things. Similarly, you will find also several subsystems in receivers. Now I'll give you some examples of systems. First one, consider yt equals to 4 times x of t. So what is this? So if you apply x of t as at the input side of the system, you will find the yt, which is the 4 times of x of t. So if this is one signal, okay, I have done one signal, and corresponding output will look like this. So it's 4 times of this one. So easily we can see that this signal is amplified version of xt. So this is an amplifier. Its purpose is to amplify the weak signal, okay, and it will produce some amplified signal. And in one example is that in loudspeaker you will find such amplifier. So this is one subsystem there. So first stage is amplifier, and then you will find one speaker. So the weak signal, the voice signal or music signal, whatever it is, that weak signal is first amplified and then it is fed to speaker and we will get louder sound. This kind of amplifier we can easily design with the help of electronic devices like BJT, bipolar junction transistors, MOSFET, operational amplifier, etc. Second one, y of t equals to 0.2 times x of t. Very similar, only difference is that here the factor is 0.2. So if this factor that is multiplied with xt is less than 1, then we will call it attenuated. Means if we want to reduce the strength of the signal, input signal, then we will multiply with one coefficient, that value should be less than 1. Okay, so this kind of attenuation, sometimes it is, so intentionally we will do with these things to reduce the strength of the signal. Okay, suppose the incoming signal is having a huge strain, but you want to reduce it because that signal is too strong to feed to your devices, so you need to reduce it first. Okay, and sometimes we'll get this kind of attenuator in practice, like in channel, communication channel. So whatever you will send from transmitter, and at the receiving side you receive very weak signal. Okay, so then that is due to the attenuation. And third one, y of t equals to x of t minus 3. So what is this? Now I have taken one example. So suppose this is one triangular signal. So it will start from 0. It is having maximum peak, that value is 1 at 4, and at 6 it is again 0, and it will remain 0 forever. Right? So this is the signal. Now if it is applied to the system, and system behavior is this one, y of t equals to x of t minus 3, Now you see at t equal to 3, y of 3 will become x of 0 because x of 3 minus 3 is 0. So same x of 0 is now visible, or you will get at y of 3, right? So this y of 3 is same as x of 0. Similarly, y of 7 will be same as x of 4, and y of 9 should be same as x of 6. Okay, so meaning is that this total xt signal is little bit shifted to right side, and it is exactly shifted by 3 seconds. So this indicates 3 seconds. So t minus something, that is basically shifting right side. So this kind of system is called delay system. Okay, so output is delayed little bit. So in this case it is delayed by 3 seconds. Now next one, y of t equals to alpha times x of t minus tau, where alpha is within 0 to 1 and tau is positive. So you see, if alpha something is multiplied, I said it is within 0 to 1, then it is for attenuation, and tau is positive, that is minus t minus tau, then it is a delayed version. So system will provide one delay as well as one attenuation. Okay, thus we can say system is having delay and attenuation, right? And this kind of system will get in communication channel, not get exactly, we want this kind of communication channel. Okay, so that channel is called distortion-less channel. If channel characteristics is like this, then there is no distortion, just only some attenuation and one delay. So attenuation is fine, because if something is reduced, that we can amplify it, we can correct it. Okay, and if certain delay is there, that is also tolerable, because signal is not modified, it is not having any distortion, shape is not distorted, thus we'll get the similar signals just after certain time. Okay, so in communication, if delay is little, then it is permissible, and if it is having a constant attenuation, that's also fine. So you want distortion less channel. Next one, y of t equals to x squared t. This is square device, we write in this way. This is square device, so output is always square of the input. Okay, so this kind of square device we can implement using diode also. Next, y of t equals to mt cos omega ct. So what is this? Here mt is one signal, input signal. So this is called modulation in communication systems. mt is exactly message signal, input signal. Cos omega ct is your carrier signal, and yt is called as modulated signal. So this kind of modulation is called DSB-SC, double sideband surface carrier modulation. Okay, one type of modulation, right? So if you look here, so this is your complete system. So if you apply xt here, and this output is yt equals to mt into cos omega ct. So basically the system is having two subsystems. One is multiplier, and other one is one local oscillator, which will generate this carrier signal cos omega ct. Okay, so local oscillator will generate cos omega ct, and then it is multiplied with input signal xt, will get the output signal yt, which is modulated signal. Okay, so if I apply this kind of message signal, you see, whenever this cos omega ct is multiplied, so generally omega c is very high frequency, so you will find a modulated signal like this, and this is called envelope, right? So this is useful for communication purpose. Every communication system will have modulator in transmitting side, and in demodulator you will find that this modulated signal is converted back to the message signal, and that is used in receiving side, because we need at the end the message signal back, right? So whenever there is a modulator in transmitting side, there should be one corresponding demodulator in receiving side. Okay. Now next example, yt, that is integration of x of tau d tau, and this is minus infinity to t. It's a function of time. This upper limit is small t. Okay, then only you will get y function of time, and that is called y of t. So this is called an integrator. We can design this integrator using op-amp easily. So this is the block. So this is one op-amp, and it is connected in inverting terminal, the signal xt, through this R, and this feedback element is one capacitor. Okay, this output y of t that we can express. So y of t will be simply minus 1 upon RC, okay, and integration x of tau d tau. So easily we can prove this thing, right? So this is one integrator. So if I apply one unit step signal to the input side of this integrator, so you see this is a constant. So if I integrate the constant, you will find that its value is 1. So its integration is 1 into t. So you will find RAM signal. So it is growing. Continuously it is increasing. That is called unit RAM signal. So if you apply unit step signal at the input side of integrator, you will find unit RAM signal at the output of the integrator. So similarly, differentiator yt equals to dx dt, it's a differentiator. So there R and C just we can interchange. So capacitor is connected here and R is connected here, and you will find that yt equals to minus RC times dx dt. Okay, so if you apply one RAM signal at the input side right now to differentiator, so derivative of t is constant, that is 1. So you will find one unit step signal. Now next one is the RC circuit. Okay, so one practical circuit we can consider the RC circuit. It's containing resistance and capacitor, one resistance here, one capacitor here, right? So they are connected in series, and we have applied one input signal VIT, and this is the corresponding output V0T, which is taken across the capacitor. Now what is the relation between V0 and Vi that will give you the characteristics about the systems? So system model should be defined by some mathematical equation between the input and output signals, right? The variables. So here Vi and V0, some relation should be there. So here we will try to get some differential equation for these systems. Okay. So I'll consider that the current flowing in the circuit is I of t. So this is no load condition. So whatever current is coming through this R, it is going through the capacitor, and capacitor current is given by C times dV0 dt. The voltage across capacitor is V0. So C into d dt of capacitor voltage. Now this total input voltage is VIT, that is equals to the voltage drop across resistance plus voltage stored across capacitor. Okay. So voltage drop across resistance is R times IT, and voltage across capacitor is V0T. So addition of these two will give you total input voltage VIT. So now I can replace IT as by this C dV0 dt. So we'll get RC dV0 dt plus V0 T equals to VIT. So this is one equation, one differential equation, that is the model for this RC circuit. Okay, so this kind of model we'll be using to define the systems, right? Then classification of systems. We can classify this kind of these systems in several ways. Okay, it could be linear or non-linear system. This is one category. time invariant, time varying system, causal, non-causal system, stable, non-stable, unstable systems, okay, static and dynamic system, invertible and non-invertible systems, and last one is continuous and discrete systems. So all the systems, this kind of systems, classification of systems, every group will be discussed in detail in subsequent lectures. So please keep watching. So if you enjoy this video, you may subscribe this channel if you have not subscribed yet. And please like the video and share it with your friends or your own persons who may like this video. So thanks for watching.